Logarithms. Have you ever heard, COVID infection rates have been growing exponentially? Or Zoom video conferencing has seen exponential growth this year due to social distancing restrictions? What does it mean to be growing exponentially? Exponentially as opposed to what? We've got two graphs here. Which graph is linear growth and which is exponential growth? What are the equations of the two lines? In this case, the green line is y equal to 0.5x, or y equals half x, which you'd probably recognize as being in the y equals mx plus b format, or y equals ax plus b format. The purple line, however, has the equation y equals 1.07 to the exponent x. The x being the exponent, so the variable is in the exponent, is what makes it exponential. The growth is happening as a result of an increase in the value of the exponent. So how does this relate to logarithms? Logarithms, or logs, allow us to find solutions to equations where an unknown is in the exponent. For example, y equals 2 to the exponent n plus 1. You've got n plus 1 in the exponent. How would you find the value of n? This happens a lot in the world of finance, where you're talking about loans and interest rates. It also comes up a lot in biology when you're talking about the population growths or the growth of plants. Let's back up a little bit and start talking about inverse operations. So in mathematics, there's generally an operation that does the opposite of another operation. For example, the opposite or inverse of adding is subtracting. That's probably the most obvious example. So 3 plus 5 equals 8, and conversely 8 minus 5 equals 3, and similarly 8 minus 3 equals 5. So we've got inverse operations. They're kind of complements to each other. You can add things together and you can subtract them. Multiplication and division also give us the same inverse operations. 3 times 5 equals 15, and I've included some other notations here. So 3.5 also means 3 times 5, and 3 bracket 5 is also 3 times 5. So there are different ways of writing a multiplication statement. Similarly, we've got different ways of writing a division statement. We've got 15 divided by 5 equals 3, where we're using the divided by sign. You can also have 15 slash 5, which is equal to 3 again, of course, and then you can have 15 over 5. When we're talking about squares and square roots, we're also talking about opposites. So 3 to the exponent 2 means 3 times 3, which of course is equal to 9. The opposite or inverse action of that, of squaring a number, is to find the square root of it. So the square root of 9 is 3. And there are different notations for that as well. So it's most correct to include the 2 by the radical symbol as shown in the first statement, where it's 2 radical symbol 9 equals 3. However, when the 2 is not included and there's no other number included, it's understood to be the square root. So in the second example, where I've got square root of 9 equals 3, it's understood to be a 2 there. Similarly, it's possible to put an exponent with a fraction. And if you have a fractional exponent, that implies you're finding the root. So y to the exponent 1 over 2 is also equal to 3. Note that the root symbol is referred to as the radical symbol. 2 to the third exponent, or 2 cubed, is equal to 8. It means 2 times 2 times 2. The opposite, or the inverse function, is finding the cube root. So we've got 3 radical symbol 8 is equal to 2. Or 8 to the exponent 1/3 is also equal to 2. We can say that the cube root of 8 is 2, or the third root of 8 is 2. Similarly, we can find the fourth root of a number. Note that the radical sign without an index number means square root. Let's talk about squares, cubes, and roots in plain English. When you see the radical sign with a number, it means what number multiplied by itself gives us n, or what number to the exponent 2 gives us n. You can think of it as like a question mark, an unknown to the exponent 2 is equal to n. Similarly, the cube root of n means what number multiplied by itself 3 times gives us n, or what number to the exponent 3 gives us n. When finding the roots, we're trying to find the base number that is raised to the specific exponent. 10 to the third means 10 times 10 times 10, which is equal to 1,000. 10 to the third can be written as 10 with the exponent 3, or it can also be written with 10 with a caret symbol and 3. We use this typically on computers or in programming, and your calculator may also use that same notation. When we're writing it, however, you typically use the 10 to the raised third exponent. Logs are the opposite of exponents. In the same way that subtracting is the opposite of adding, logs are the opposite of exponents. So a log of base 10 of 1,000 is equal to 3, which means that you have to take 10 to the exponent 3 to get 1,000. You can think of the log base 10 1,000 as being a question of, if you've got 10 to the exponent x is equal to 1,000, what is x? In this case, it's 3. There are some memory aids which some people use to help you remember how this works. One of the rules says, little to the right equals middle. Let's take a look at what that means. Little to the right equals middle. If we take an expression like log 4 of 1024 equals x, what this rule tells us is that we take the little number, which is written down below, raise it to the whatever's on the right, and that will give us the number in the middle. We know that in practice, we take that to mean 4 to the x is equal to 1024, which we know then is 4 times 4, 16, times 4 again is 64, times 4 is 256, and times 4 is equal to 1024. In that case, we can see we've got 1, 2, 3, 4, 5 4s. We can conclude that log base 4 of 1024 is equal to 5. The other memory aid, called the snail method, basically if you take a look at the shape of a snail shell, does kind of a spiral. What they're saying is to take a look at your statement, start at the 4, and spiral out and around. That tells you then that you've got 4 to the x equals 1024. Whichever method helps you remember it, it's important. Maybe you don't need either of these methods. Just do whatever works for you. Just some information about notation and the terminology that goes along with it. Looking at the exponential form, we can see that we've got the base, which in this case is 3. Then there's the exponent, which of course is 2, and together they produce the power, which is 9. In logarithmic form, we've again got the base, which is 3, the argument, which is 9, and they produce a logarithm, which in this example is 2. If you've got log base 3 of 81 equals to x, that's the same as saying 3 to the exponent x is equal to 81. When we work it out, we can see that log base 3 of 81 is equal to 4. Log base 4 of 1024 is x. So 4 to the exponent x is 1024, and therefore the log base 4 of 1024 is equal to 5, because we'd have to raise 4 to the exponent 5 to get 1024. When finding logs, we're finding the exponent that we need to raise the base to in order to produce the argument. At this point, it can be easy to confuse logs and roots. They're both dealing with exponents, and it's easy to get them messed up in your head. We're trying to find the value of x, and n is given. When we see the cube root of n equals x, it means x to the exponent 3 is equal to n. When finding roots, we're trying to find the base number x that is raised to the specified exponent 3 in this case to get to the given value of n. The unknown is the base. When we see log base m of n is equal to x, it means m to the exponent x is equal to n. So when finding logs, we're finding the exponent x that we need to raise the base m to in order to get the specified number n. So in this case, the unknown is the exponent. And you can see that by looking at the two equations. X cubed equals n, the x is the base number, whereas in m to the x equals n, the x is in the exponent position. Now, at a practical level, we need to think about how to do exponents and roots on our calculators. We know that 10 cubed is equal to 10 times 10 times 10, which of course is equal to 1,000. However, that's not always practical, particularly when you get into larger exponent numbers. So we need to be able to do exponents on our calculator easily without having to type them all out or write them all out one at a time. Imagine if you had 10 to the 32nd exponent. You're not going to be typing 10 32 times. So on most calculators, the button looks like the caret symbol, or it's a little roof or pointy arrow pointing up, or in some cases it'll say x to the y or x to the n. So if you can find those buttons on your calculator, so that's what you're going to do when you're doing exponents. Now when you're doing roots, such as cube root of 1,000 equals 10, that starts to get a lot harder unless it's really obvious numbers like that. So to do roots on your calculator, you need to find a button that's going to help you out there. Typically it's going to look like an x with a radical symbol, or an x radical symbol and a y, or some combination of letters like that. To use it, to solve the problem above, you'd press the 3, then you'd press your button, then type 1,000 and press equals. The process may be slightly different on different calculators, so check out the manual or do some practicing with numbers where you know what the answer should be. Similarly, we want to be able to do logarithms on our calculator. Your calculator probably doesn't have a log base n y button. Some do, so you can look for it, but a lot of them don't. Definitely the cheaper calculators don't. You likely just have a log button, which is log base 10. There is a handy bit of knowledge that can help you though, and that is that log base a of b is equal to the log of b over the log of a. So that means the log base 10 of b divided by the log base 10 of a gives you the log of base a b. Sounds like a whole bunch of letters, but it works. That's dividing the base 10 logs one by the other. If you're rusty on working with exponents and roots, you should check out the relevant math antics videos on YouTube. If you go to my site and click on the Mathematics MAT 504 CST link at the bottom of the page, from that page in the Logarithms and Finance section, you'll see the recommended links on YouTube.